Hello students, welcome to PRP lecture videos. In this video, we are going to discuss about the topic geometric distribution. It is come under the discrete random variable. So that's why this is a discrete random variable distribution. In this video, we are going to see that the definition of geometric distribution, applications and moment generating function. After finding MGF, we have to find a mean and variance. Okay, so let us see one by one. First, the definition of geometric distribution. If the random variable x denotes the number of trials required for the first success in independent repeated Bernoulli trials with the probability of success p, then the probability mass function is p of x equal to q power x minus 1 into p, where x equal to 1, 2, 3 up to etc. Okay, where q equal to 1 minus p. So what is the random variable x? Number of trials required for the first success. How many Bernoulli trials are there? Independent repeated Bernoulli trials. Okay. So however the trials are goes on, we have to take the first success. That is P. Remaining under Q. Let us see the note. This is known as the Pascal's form of the geometric distribution. So what we have seen, that geometric form is Pascal's form. The possible probabilities are through the formula is P, QP, Q square P, Q power 3P up to etc. So this is look like what? Geometric progression. That's why the name of the distribution is geometric distribution. So the random variable x follows the geometric distribution. That's why x is called geometric random variable. Okay. Now the applications of geometric distribution. I'm going to take sports. Time until the first goal in the football match, first six in the cricket match, first win, it may be chess or whatever the game. Okay, so first six or first goal, the players are playing well, it takes more than 20 minutes, 30 minutes and etc. At what time they put the first goal, that is the first success P. Okay, at what the player meets the several balls, the player when he hit the first six, that is the P. Okay, like that the first win. Same way in quality control, a person find the he checked so many number of items. When he find the first defective item, that is the first success P. Okay, and call centers. The person working in call centers, he received so many calls. At what call he received the complaint, that is the success P. And gaming, number of tries until the first win. See, let us understand the concept through this example. Sachin Tendulkar with geometric distribution. Okay, so imagine Sachin is batting, and the match is very crucial match. He needs to get more score. That's why he tries to get every ball. The probability of hitting six in one ball with probability 0.2. That means out of 10 ball, he may put 2 6. Remaining 8 balls may be failure. Failure means it may be single 1, 2, 3 or boundary or dot, whatever it is. But we have to calculate only 6 alone. The probability 2 out of 10 balls. So what is the chance that Sachin hits his first 6 on the fourth ball? So we are going to find the at fourth ball he may hit the 6. So what is the chance? See, first ball no 6, second ball no 6, it may be 1 or 2. Third ball also no 6, it may be 4 also. But fourth ball he put the 6. Have you understood the concept? Okay. Now what is the probability? Probability of no 6 in one ball. A little bit the space is there, it is 1. Probability of no 6 on ball, that is failure. Q equal to 1 minus P. So out of 10 balls, only 2 balls alone 6. Remaining 8 balls failure only, no. That is called 0.8. Okay. For the first 3 balls, Sachin must not hit a 6. So first 2 ball is failure, second ball is failure, third ball is failure. So Q into Q into Q, Q power 3, 0.8 power 3. So what about the fourth ball? 6. So fourth ball 6 means success. So multiply by P. So Q power 3 into P. So 0.8 power 3 into what is the probability? Success 0.2. So the geometric distribution formula says P of x equal to x equal to q power x minus 1 into P. So here number of trials are 4. So P equal to 0.2, Q equal to 0.8. Substitute here P of x equal to 4 equal to 0. This is power 4 minus 1, please understand, into 0.2. So 0.8 power 3 into 0.2. Simplifying this, we can get 0.512 into 0.2. And here 0.1024. Please note that here typing mistake, 0.8 power 4 minus 1. Okay. Now we come to the moment generating function, MGF. What is the formula? P of x equal to x equal to q power x minus 1 into P. X equal to 1, 2, 3. Here one term is missing. What is missing, comma, dot. Okay. Now MGF formula is mx of t equal to expectation of e power tx. So this is one discrete, So summation x equal to 1 to infinity e power tx into probability mass function. So what is probability mass function? Q power x minus 1 into multiply e power t into e power minus t. So e power t into e power minus t. So e power minus t, for example, let us see, I will explain now. E power t into e power minus t. So here e power tx is there only now. Simplifying this, we can get e power t into x minus 1. See, summation e power t into e power t x minus 1. So remaining things q power x minus 1 into p. Now, what is the answer? Here the summation depends on only x. So p and e power t is constant. So we have to take outside. Now, why we have to form summation x equal to 1 to infinity q e power t power x minus 1? We have a reason. See the reason. The summation is a geometric series. See, summation x equal to 1 to infinity r power x minus 1 can be written as 1 by 1 minus r if r should be less than 1. Look at the previous one. It is look like what? P e power t into summation q e power t x minus power x minus 1. So that we can easily write mx of t equal to p e power t is outside. Inside the summation we can write 1 minus q power e t. Here r value equal to q e power t. So here q into e power t strictly less than 1. Okay. To find the mean. To find the mean, we need the first derivative of mx of t. Here mx of t is available. I am taking this is u and this is v. Now, the differentiation is u by v formula. What is u by v formula? Denominator v square, numerator v into u dash minus u into v dash. Okay, so here u equal to p e power t. So what about u dash? P is a constant, e power t differentiation, e power t only. Okay, v equal to 1 minus q into e power t. What is v dash? 0 minus q into e power t. So substitute in this case v 1 minus e power q e power t and u p into e power t, p I kept here, and minus u dash, sorry, minus v dash minus q into e power t and etc. Okay, so from the both the cases I kept p outside. Denominator 1 minus q into e power t whole square. Okay, now substitute. Now simplify this one. P e power t is common, so take it outside. 1 minus q e power t, minus into minus plus q into e power t. Denominator 1 minus q into e power t whole square as it is. Now I am going to simplify this one. This and this will be cancelled. P e power t divided by 1 minus q e power t whole square. See, this term and this term will be cancelled. So p e power t divided by 1 minus q into e power t whole square. Okay, so this is first derivative of mx of t. Okay, right. Now we are going to substitute t equal to 0. See, we're going to substitute t equal to 0. See what happened? When you substitute t equal to 0, p into e power 0 divided by 1 minus q into e power 0 whole square. So e power 0 value 1. So P divided by 1 minus Q whole square. P divided by 1 square. So 1P and P will be cancelled. So answer 1 by P. Okay. Now mean value equal to E of x equal to 1 by P. Now we are going to find the variance of geometric distribution. Okay, so the required thing is second derivative. Already we have the first derivative of moment generating function. So let us see the second derivative. Take this one u1 and take this one v1. See what is u1 p e power t, v1 equal to 1 minus q e power t whole square. So u1 dash value p into e power t. E power t differentiation, e power t only. v1 differentiation, first we differentiate the square. 2 into 1 minus q into e power t. Then we differentiate the inside the bracket 0 minus q into e power t. So we are going to substitute in this ms double dash of t. u1 dash v1 minus u1 v1 dash divided by v1 square. After substituting this one, I have found p e power t. See here p e power t and p e power t. Both two terms having common term. So I am going to take common p e power t. So inside the bracket what we have 1 minus q e power t whole square minus and minus plus. So 2q into e power t 1 minus q e power t. That's all. Okay. Now see the similarity. Here 1 minus q e power t and 2 times of 1 minus q power t 4 times. So we will take 1 minus q e power t common. Here one term cancel, here one term cancel. So it comes 3. Okay. So here 1 minus q e power t plus 2q e power t. Simplifying this, we can write only q e power t. Let us see. P e power t into 1 minus q e power t into 1 plus q into e power t divided by 1 minus q e power t power 4. Okay, simplifying this, we can cancel this 3. That's all. ms double dash of t equal to p e power t 1 plus q into e power t divided by 1 minus q e power t whole cube. Now we are going to substitute t equal to 0. See, when we substitute t equal to 0, what happened? This is p e power 0 value 1. 1 plus q into e power 0 value 1 divided by 1 minus q power 3. Okay, so p into 1 plus q divided by 1 minus q power 3. 1 minus q is nothing but p. So p into 1 plus q divided by p cube. P and q will be cancelled. 1 plus q divided by p square. Now we have the enough data to find out the variance. What is the formula? Mu2 dash minus mu1 dash square. So mu2 dash is nothing but 1 plus q divided by p square. Already we have found mean equal to 1 by p. So mean square 1 by p square. So take LCM p square. Take LCM p square. Numerator 1 plus q minus 1. 1 will be cancelled. So q by p square. Hence